Hello and welcome to flameinstitute.com. Today we are doing the questions of thermodynamics, modes of exchange energy. The first question, the work done when a gas compressed by an average pressure of 0.50 at atomic atmospheric pressure so as to decrease its volume from 400 centimeter cube to 200 centimeter cube, then the work done is equal to minus P sigma V, change in enthalpy. So the pressure is minus 0.50 into what is the change in enthalpy, change in volume is 400 to 200 centimeter cube, that means 0.2. So the right option is 0.1. That means 0.1 into 101.3 joule is equal to 10.30 joules. So, first option is the correct option. Temperature of 1 mole of a gas is increased by heat constant pressure. Work done is R, 2R, R by 2, 3R. PV is equal to RT at temperature Tk. P is V plus delta V, that is equal to RT plus 1 at a temperature. So T plus 1 K, therefore PV plus P delta V plus RT plus R, that is equal to P delta V is equal to R. So first option is the correct option. A certain electric motor produced 15 kg of energy each second as numerical work and lost 2 kg as heat to surroundings. What is the change in the internal energy of the motor and its power supply each second? The right option is minus 17 kilojoule. 2 liters of N2 at 0 degree Celsius and 5 atmospheric pressure are expanded exothermally against a constant external pressure of 1 atomic until the pressure of gas reaches 1 atom, so assuring gas to be idle. Calculate work to be done. Work of expansion. The right option is minus 810 joules. When work done by a system was 10 joule, the increase in the internal energy of the system was 30 joule. The heat Q supplied to the system was. The right option is 40 joule. The work done when 6.5 gram of zinc reacts with dilute HCl is in an open beaker at 298 Kelvin is. The right option is C 3 minus 247.76 joule. The work done in heating 1 mole of an ideal gas at constant pressure from 15 degree to 25 degree is. The right option is fourth, 19.87 calories. Internal energy U and change in internal energy. A gas expands from 1.5 to 6.5 liter against the constant pressure of 0.5 atmospheric pressure, and during the process of the gas also absorb 100 joule of heat. The change in the internal energy of the gas is. The right option is delta U is equal to Q plus W. So Q is 100 joules minus delta U is 100 joules minus 0.5 atmospheric pressure, or 6.5 liter minus 1.5 liter. So the right option is minus 153.3 joules. The third option is the correct option. 10 gram of argon gas is compressed isothermally and reversibly at a temperature of 27 degree from 10 liter to 5 liter. Calculate Q and delta H for this process. Atomic weight of the argon is 40. W is equal to minus 2.303 Rn nRT log 10 B2 minus B2 by B1. So Q is equal to delta U minus W. Now delta H is equal to delta U plus delta PV. That means P1 V1 is equal to P2 V2. That means PV is equal to constant. So the right answer is plus 103.99 calories. A liquid is stirred in thermally insulated container for about 2 hours. Which of the following is correct? Work is done on the system W equal to 0. Internal energy will increase delta U greater than 0. So first option is the correct option. Law of thermodynamics. A system absorbs 20 kg of heat and also does 10 kg of work. The net internal energy of the system increase by 10 kg, decrease by 10 kg, increase by 30 kg, decrease by 30 kg. The right option is delta E is equal to Q minus W. That means first option is the correct option. If a gas absorbs 200 joules of a heat and expands by 500 centimeter cube against a constant pressure of 2 into 10 raised to power 5 n meter square, then change in internal energy is delta E is equal to Q minus W. So Q is equal to P dot B delta B. That means 200 minus 100 is equal to plus 100 joules. So third option is the correct option. In an insulated container, 1 mole of liquid molar volume 100 milliliter and 1 bar liquid is steply taken to 100 bars. When volume of liquid decreases by 1 milliliter, find delta H in the process. Volume of 1 mole liquid is equal to 100 milliliters at pressure. So 9900 bar milliliter is the correct option. Exothermic and endothermic reactions. Which of the following is an endothermic reaction? Absorption of energy, heat energy is endothermic energy. Delta H is equal to plus V positive. So second option is the correct option. When 10 grams of methane is completely burnt in oxygen, the heat evolved is 560 kg, but is the kilojoule, but is the heat of combustion of the methane. CH4 plus 2O2 giving you CO2 plus 2H2O. That means minus 896. So the right option is 3. Measurement of delta H and delta E. The difference in delta H and delta E for the combustion of methane at 27 degrees Celsius would be minus 1200 calories. For the reaction C2H4 3O2 giving you 2CO2 plus 2H2O is the right option is delta N equal to minus 2. So minus 1420 kilojoule is the correct option. One mole of the ideal gas expands freely at 310 Kelvin from 5 liter volume to 10 liter volume. The delta E and delta H of the process are respectively 0 and 5, 0 and 5 into 30, 0 and 0, 5 into 0. The right option is for the ideal gas delta is equal to 0. So 0 and 0 is the correct option. The standard heat of the formation values of SF6 gas S and F are minus 1100, 275 and 80 joules per mole respectively. The energy SF bond energy in SF6 is delta H is equal to delta HS plus 6 delta HF minus delta HSF6. So 275 plus 6 into 80 minus of minus 1100, that is equal to 1855. Average is 1855 upon 6, that is equal to 309.17. So first option is the correct option. The heat of dissociation of CH4 and C2H6 are 360 and 620 respectively. From these, the CC bond energy is of ethane in the ethane can be evaluated as average CH bond energy is equal to 360 upon 4, that is equal to 90. C2H6 CH bonds are present energy required to 6C minus H is equal to 90 into 6, that is 540. So energy of CC 620 minus 540, that is equal to 80. So first the third option is the correct option. 1 gram of graphite is burnt in the bomb calorimeter in excess of oxygen at 298 Kelvin and 1 atmospheric pressure according to the equation C plus O2 giving you CO2. During the reaction, temperature rises from 298 Kelvin to 299 Kelvin. If the heat capacity of the bomb calorimeter is 20.7 kilojoule per mole, what is the enthalpy change for the above reaction at 298 Kelvin and 1 atmospheric pressure? The right option is minus 2.48 into 10 raised to power 2 kilojoule per mole. The combustion of 1 mole of benzene takes place at 298 Kelvin to 1 atmospheric after combustion. CO2 and H2O are produced and 3267.0 kilojoule of the heat is liberated. Calculate the standard enthalpy of formation delta H of benzene, standard enthalpy of formation of CO2 and H2O, and minus 393.5 kilojoule and minus 285.83 kilojoule per mole. The correct option is 48.51 kilojoule per mole. Delta H minus delta U for the formation of carbon monoxide from its element at 298 Kelvin is minus 1238 0.78 joule per mole. For reaction CO2CO plus CO2 is giving you 2CO2, delta H is minus 560 kilojoule per mole. In 1 liter vessel at 500 Kelvin, the initial pressure is 70 atmospheric pressure, and after the reaction it becomes 40 atmospheric at constant volume of 1 liter. All the above gases show significant deviation from ideal behaviors. 1 liter atmosphere is equal to 0.1 kilojoule. The change in the internal energy will be, the right option is minus 530 kilojoules per mole. Enthalpy of dissociation. The bond energy of the OH bond is 109 Kelvin calories mole per inverse. When a mole of water is formed, then the right option is, when water 2 OH bonds are present and energy is released, so 2 into 109, that is equal to 218 calories energy releases. So first option is the correct option. Given the bond energies of N triple bond N, NH bonds are 945, 436 and 391 kilojoule per mole respectively. The enthalpy of the reaction N2 plus 3H2 giving you 2NH3. The right option is N2 plus 3H2 giving you 2NH3. So, and 945 plus 3 into 436 is giving you 9 into 391. Delta H is bond energy of reactant, bond energy of product. So, first option minus 93 is the correct option. Enthalpy of combustion. When 39 grams of benzene undergoes combustion, the heat liberated is 78 gram of C6H6 combustion, 718 kilocalories. 39 gram C6H6 combustion, 718 into 39 upon 38, that is equal to 359 calories. So second option is the right option. According to the equation, the energy evolved when 3.9 gram of benzene is burnt in air will be, the right option is 78 gram benzene evolves 326 kilojoules. Energy 3.9 gram benzene evolves is 3.9 into 326 upon 78, that is 163.2 kilojoules. So fourth option is the correct option. Human body requires 22,370 kilocalories of energy daily. The heat of combustion of glucose is 790 kilocalories mole. The amount of glucose required the daily combustion of 180 grams glucose giving you heat of combustion is 790 calories. So how many grams glucose required? The 2370 calories, that is 540 grams. So second option is the correct option. Enthalpy of neutralization. If H positive and OH negative giving you H2O, delta H is equal to minus 57.3 kilojoule, then the heat of neutralization, of complete neutralization of 1 mole H2SO4 by a base is H2SO4 giving you 2H positive plus SO4 2 negative. Then 2 into 5 minus 57.3 kilojoule is equal to minus 114.6 kilojoule. So second option is the correct option. If 9.8 grams of H2SO4 is neutralized exactly with the strong alkali, the heat evolved in delta H of neutralization is 13.6 kilocalories. The right option is H2SO4 giving you A2H positive plus SO4 2 negative. 98 is giving you 27.2 calories. So 9.8 is giving you 2.72 calories. So third option is the correct option. Equal volume of the molar HCl and H2SO4 are neutralized by dilute NaOH solution and X calories and Y calories of heat are liberated respectively. Which of the following is true? X is equal to Y, X is equal to Y by 2, X is equal to Y upon 3, X minus 2 equal to 2, Y. H2SO4 is a dibasic acid, so that's why 2x is equal to y. That means x is equal to y upon 2. So the second option is the correct option. The heat of a neutralization of NaOH and HCl is 57.3 kilojoule and with HCN is 121.1 kilojoule. 12.1 kilojoule. The heat of ionization of HCN is HCN is a weak acid, so 57.3 minus 12.1 is equal to 45.2 kilojoules. So right option is second. If X calorie and Y calories are the delta H values of ionization of weak acid and weak base respectively, delta H of neutralization of the WA and WV is minus 13.7 plus X plus Y calories. So, minus 13.7 plus X plus Y calories is the correct option. Equal volume of methanic acid and sodium hydroxide are mixed. If X is the heat of formation of water, then the heat evolved on the neutralization is more than X, equal to X, twice of X, less than X. The correct option is methanic acid is weak acid, so less than X is the correct option. Enthalpy of formation. When hydrogen gas is burnt in chlorine, 2000 calories of heat is liberated. Then during this, the 3.65 grams of HCl delta H is formation. H of formation of HCl is 3.65 gram of HCl is equal to 2000 calories or 36.5 gram of HCl is equal to 20 calories. So second option is the correct option. The next is delta H dot for H2O2 and H2O are minus 188 kilojoule per mole, the minus 286 kilojoule per mole. What will be the enthalpy change of the reaction? The enthalpy change of the reaction is minus 196 kilojoule per mole. Heats of formation of SiO2 and MgO are minus 48.24 and minus 34.7 kilojoule respectively. The heat of the reaction is 21.64 to minus 21.16, 13.62 or 13.62. The correct option is delta H is equal to H2 minus H1. So that means minus 21.16 kilojoule. Next, A square plus A2 and B2 are diatomic molecules. The bond capables of A2, AB and B2 are in the ratio 1:1:0.5, 0.5, and enthalpy of formation of AB from A2 to B2 is 100 kilojoules, minus 100 kilojoules per mole. What is the bond energy of A2? The bond energy of A2 is given that let bond energy of A2 be X, then energy AB is also X. The bond energy of B2X by 2 enthalpy of formation of AB is equal to minus 100 kilojoule per mole. A2 plus B2 is equal to 2AB. So that means fourth option is the correct option. As per the reaction, N2 plus O2 giving you 2NO2, that is delta H is equal to 66 kilojoule, and the molar heat of formation of NO2 is equal to minus 66 plus 66, 33 minus 132. N2 plus the 2O2 giving you 2NO2, that is delta H is equal to 66 kilojoule. For 1 mole of NO2 is giving you 66 upon 2, that is equal to 33 kilojoules. Enthalpy of atomization, that is energy required to dissociate 4 grams of H2 into free atoms, is 200 kilocalories, and the HH bond energy will be 104, 1040, 10.4, 208. 4 grams of H2 is equal to 2 moles. So 2 moles of HH bond energy is equal to 208 calories. 1 mole is equal to 208 upon 2. So that means 104. So first option is the right option. The enthalpy change when 1 gram of water freezes at 0 degrees Celsius and 1 atmospheric pressure is delta H fusion is equal to 1.435 kilocalories per mole. So the right option is 1 mole water delta H is equal to minus 1435 calories, and 1 gram water delta H is equal to minus 1435 by 18. So the right option is minus 79.7. Enthalpy of phase transition. Given that C graphite is giving you C gas delta H is equal to plus 719.7. C diamond is giving you C gas delta H is equal to 714.8 kilojoule. The delta H of the following is 1.9, minus 1.9, 0 or 714.8. The right option is delta H graphite minus delta H diamond. So that's why 1.9 kilojoule is the correct option. At 25 degrees Celsius, the heat of formation of H2O liquid is minus 285.9 kilojoule mole per inverse, and that of the H2O gas is minus 242.8 kilojoule per mole. The heat of vaporization of water at the same temperature is delta H H2O is minus delta H H2O giving you gas minus liquid. So 43.1 kilojoule per mole is the correct option. Enthalpy of dilution. Delta X is given by delta X is equal to hydration energy minus lattice energy for salt. Delta X is found to be minus 300 kilocalories per mole. Then on increasing the temperature, its solubility in water decreases, increases, remains same, increase initially and then decreases. The right option is increases. Given that Zn plus half O2 giving you ZnO plus 35.25 kilojoule and this reaction, then the right option is equation 1 and equation 2 plus equation 1 and plus equation 2. So the right option is minus 35.25 minus 9.11, that is minus plus. So minus 26.14 kilojoule is the correct option. Entropy, spontaneous process. When enthalpy and entropy change for a chemical reaction are minus 2.5 into 10 raised to power 3 calories and 7.4 calories respectively, predict that reaction at 298 Kelvin is spontaneous, reversible, irreversible, non-spontaneous. The right option is delta H is equal to negative, delta S is equal to positive, spontaneous reaction. So, first option is the correct option. The enthalpy and entropy change for the reaction is 30 and 105 joule respectively. The temperature at which the reaction will be equilibrium is 285.7 calories Kelvin. If delta H vapor of pure water at 100 degrees Celsius is 40.627 kilojoule per mole, the volume of delta S vapors is. The right option is delta S is equal to delta H upon T. So that means 40.627 into 10 raised to power 3 upon 373. That is equal to 108.9 joule per. So, second option is the correct option. The temperature at which the reaction is at 1.1 atmospheric pressure will be in equilibrium. So, the volume of delta H and delta S for the reaction are 30.58 kilojoule and 66.11 kilojoule per joule, that is respectively, and these values do not change much with temperature. So the right option is T is equal to delta H upon delta S, that means 30.58 into 10 raised to power 3 upon 66.11. So that means 462.6 Kelvin is the right option. The latest heat of fusion of ice is 5.99 kilojoule per mole at its melting point. Then the right option is delta S for fusion of 900 gram ice, delta F is freezing a liquid water are respectively. For 1 mole, the right option is 1097 joule or 21.9 joule per mole. Combustion hydrogen in a fuel cell at 300 kilojoule is represented as if delta H and delta G are minus 241.60 and minus 228.40 then of H2O, then the value of delta S of the above process is, for the 1 mole delta S is equal to delta G minus delta H upon T. For 1 mole of H2O, that is 44 joule, and 2 moles for 88 joule. So second option is the correct option. In certain chemical reaction, delta H is equal to 150 joule and delta S is equal to 100. So at 300 Kelvin, the value of delta G would be 0, 300, 330, 120. Delta G is equal to delta H minus T delta S. So 120 is the right option. What is the value of the delta G naught if equilibrium constant of a reaction is 10? Delta G naught is equal to minus 2.303 RT log. K is equal to 8.314 into 10 raised to power minus 3 mole inverse. So T is equal to 300 Kelvin and K is equal to 10. So right option is second. The reaction gives that delta G naught for Cu and Zn as 65 and minus 147.2 joule respectively. Then the standard gives energy of the above reaction. This is the equation. Then we have to find the summation of delta R G naught minus of a product minus a reactant. Then minus 147.2 minus 65.0 joule. So answer is minus 212.2. The right option is 3. This reaction delta H is given at 25 degrees Celsius. The change in entropy accompanying process is minus 20.7 mole per inverse. Then the 25 degree of the change in free energy is delta G is equal to delta H minus T delta S. So by putting the values, all the values, the right option is minus 61.2 kilocalories. Standard gives free energy change. Delta G naught is related to equilibrium constant Kp as delta G is equal to minus RT in Kp, or Kp is equal to minus E minus delta G naught RT. So fourth option is the correct option. What is the free energy change delta G when 1.0 mole of water at 100 degrees Celsius and 1 atmospheric pressure is converted into steam and at 100 degrees Celsius and 1 atmospheric pressure? The right option is condition of equilibrium, hence delta G is equal to R. So last option is the correct option.
चाय बन रही है, फिर आप चाय डाल लोगे? नहीं कर लेते। आप अपनी बड़े कप में ले लेना, मैं छोटे में लूंगा। कंप्लीट योर ऑफिस एक्सपीरियंस।